So I assume most of you use Windows. And as Windows users, you know that one of the default compression and archiving utilities is a zip utility. And what the zip utility does, obviously, is allows you to take, let's say, a directory of files and to compress them all into a single file that's much smaller than all of the uncompressed files combined. Well, we have the same utility in Linux called zip. However, the standard utilities in actually Linux gives you many more utilities that you can use for archiving and compressing files. And they're usually much more efficient. They provide for better compression, and the standards are just different. So usually if you're doing any archiving and compressing of files, you're not going to be using zip, you're going to be using a couple of other utilities, and that's what we'll be showing you today. Okay, so let's tackle archiving and compressing. As I said, there are several utilities that are provided by Linux that come standard, and they actually provide for some very good archiving and compressing routines. And of course, you use archiving and compressing for reducing the amount of space that files take up on your hard drive. They can be used for data backup, or for, let's say, you're trying to move some very large files across the network. It's much better to compress those or to stick them all in one directory and to archive and compress them than it is to just send across the uncompressed files. So let's look at a few of these. One of them is called Gzip2, and it uses something called the Gzip compression algorithm. And that's normally used because it's a very good compression algorithm. And the flip side of that, for uncompressing the file, is called unzip2. Now you see that 2 in there. That obviously should indicate that there was a bzip or bzip1, but that's no longer used because the bzip2 improves on the compression algorithm. And so it's very easy to use this, and here's an example, bzip2 large file.txt, and let's go run a few of these and see what happens when we use bzip2. So let's go to the documents directory. Let's see what we have in here. Let's see if we've got quite a few large files that you may remember working on. And so here's one that I downloaded called blackbox.txt. And so let's just take a quick look at that file. And we'll see it's just a text file. So what we're going to do is we're going to use bzip2 and then blackbox.txt, and we'll see what happens to it. And let's do this. Let's do just blackbox. So I'm doing ls-al blackbox.star. What does that mean? That means that's going to show me a long listing of all files that have black box in their name, regardless of the extension. So what happened? Well, we see that we have a blackbox.txt.bz2. The .bz2 extension indicates that it's a bz2 compressed file, and we see that the new size is 1851. If we want to see that how much this was compressed, so let's look at how much space we saved. So 1851 divided by 4460, and we'll see how that compared. So it's about 41%, 9%, 68.5% of the space just by compressing that file. So notice that the original file went away, so the blackbox.txt.bzip2 ended up replacing blackbox.txt. So if you needed to keep a copy of this for some reason, you'd want to make a copy of it first and then just archive this single file here. Let's say we wanted to bzip all of the files in here, all of the text files. We would use this, the wildcard.txt. Let's see what happens. And the reason this took so long is here's this kissme.txt that is 4.7 megabytes in size. And now let's see what files we have. And notice now that all of the files are smaller, and the kissme.txt is only a little bit smaller, and that was a binary file to start with. That wasn't a normal text file. So normally text files and some uncompressed graphics files will benefit the most from the bzip command. So, and we saw earlier that there's a bunzip2 command that's used to uncompress the files. So let's go back and blackbox.txt. Oh, in fact, before we do this, let's just look at this blackbox.txt file with our hex viewer and see what it looks like. We saw what it looked like when it was uncompressed. And there it is. Notice here at the start, you see this BZ right here in the hex viewer, and then it looks like a bunch of mismatch, random characters. The BZ indicates right here that this was compressed with the bzip compression utility. And so that's our compressed file. Right here, it's much smaller. If we use bunzip2 for blackbox.txt.bz2. Oh, that's good. I'm glad I made that mistake. Notice that there is no bunzip utility. It's been replaced by the bunzip2. And so actually, if I'd done this is good that I make mistakes, because I do make mistakes. But since there's no bunzip utility, if I just hit the tab here, notice that it completes to bunzip2. Now we can type black BL and then tab, hit enter. Notice we don't receive any feedback. Let's look at blackbox.txt. Obviously it's there because when I hit the tab, the blackbox.txt was auto-completed. And 4460, let's take a look at that file, and we have it back. Okay, let's go in and let's bunzip2 all of those files. bz2, unzip all those, ls-al, wildcard star.txt, and we have all of our files back to what they originally were. Now let's look at a little older archiving and compression utility, and it is called Gzip. And this uses the Gzip compression algorithm. And similar to what we saw with bzip2, and bunzip2, there's a gunzip, which decompresses Gzip files, and it works just the same as the bzip2 utility. So you see here, let's go in here and let's run this, and then let's compare them to see how much space each saves relative to the other one. So let's go ahead and let's make a directory called compare, and then let's copy blackbox.txt to compare, and let's name this one.txt. Let's arrow up and let's make another copy of it, and we'll name that 2.txt. Let's go to the compare directory, and now we have two copies of the same file. Let's run bzip2 on 1.txt. Let's run gzip on 2.txt. So this allows us to compare how well they compress, ls-al. And we see that in this instance, it's very close. In fact, the Gzip utility provided a little better compression than did the bzip2. And that won't always be the case. I mean, the reason they created a bzip2 was because it provided really good compression. But in this instance, they're about the same. So to gunzip the .gz file, we'll just say gunzip2.txt.gz, hit enter, arrow up to ls-al, and there's the original file. Okay, let's look at one last utility, which actually does the archiving and compressing. That is, it sticks all the files together in an archive, and then you can use compression on that. And that's called the tar command, and this has been around forever. And tar stands for tape archived, and it's used to create a single file from multiple files, and it can be used with a number of different parameters. And so again, usually you're going to use tar when you're trying to back up several files into a single file and then compress it. So here we've got an example, tar cvf. Now this is kind of weird, but notice it doesn't have the dash in front of it, and I really don't understand why, and I really don't care, but usually within arguments you have to have a dash in front of it. With tar you don't. So let's see what the C, the V, and the F stand for. The C means to create a new archive, so C is for create. So in this case we're creating a new tar file called minifiles.tar. The V means verbose, and that means to show me what you're doing. Otherwise, if you didn't have a V, it would do everything quietly like Linux usually does, but this shows you what's going on. And F means to use the file. So not only are we creating a file, we're using it with the C and the F, and the V just means, hey, show me what you're doing. And notice the 1, 2, 3 after this. The 1, 2, and 3 are the files that we want to stuff into the tar archive. So let's take a look at that, and let's actually create that exact same command and see what happens. Okay, so we've got, first I want to B unzip to this one.txt and see what we've got there. So we've got those two files. So I want to move one.txt to a file called 1. I want to move 2.txt to a file called 2. Then I want to copy 2 to a file named 3. You got that? These are commands we've already gone over before. So pause the video and do that so we can replicate that. So we've got 1, 2, and 3. And now let's tar them. Tar, create a file, show me everything that you're doing, use this file. Let me see, what was the name of that file? Minifiles.tar. Now, does it have to end in .tar? No, it doesn't. We could have named it this, minifiles.tar. But this convention just tells us, okay, when I look at it with an ls-al, I know it's a tar file. So remember, just because, if you could name it this, or you could name it football. You could do either of those. It wouldn't matter. It's still a tar file. Now let's say 1, 2, 3. Let's see what happens. So here's, with the verbose turns on, it says 1, 2, and 3. Now let's do an ls-al. We'll just arrow up. Well, interesting. It did not remove the 1, 2, and 3 files. Those are still there. But here's a file called minifiles.tar. Now, did it compress those files? Did it compress them? Well, let's go do a little math. 4460 times 3 equals 13,380. Whoa, 13,380. This file is much larger than that, so it really didn't compress it. It expanded it greatly. And this should tell you something, is that typically we just don't use the minifiles.tar. I mean, we don't just use the tar command. We're going to use the tar command along with a compression utility to make that tar file smaller. Let's see if we can see the contents of this minifiles.tar. We're going to pipe that to less. And it looks like, what have we got here? We've got a lot of information that wasn't in those files. Now you see here's the ASCII files that we saw previously, but also there's a lot of header information up here. It says 1 right here, then it's got a lot of information in here. Here's PC, that's the user in the group. So it looks like it's storing both the name of the file. It looks like it's storing some modified access and created times, and some user information for each file. So instead of just having the text file, it's also storing additional information regarding the file, and that's why the 3 files stuffed together are much smaller than just the text of the file. Let's type Q to quit, and let's go back to the notes for a second. And scroll down. Come on, let's scroll all the way down. Why is it not allowing me to scroll? For some reason it's not. Okay. We'll just look at this right here. Okay, here's an X. Notice up here we use the C for create a file. The X says to unarchive the files, extract them. Notice we still have the V for verbose and F. You're always going to have an F there if you've got a file name here, because the F just says use this file. So F means, hey, I'm going to give you a file name. So X for extract, V for verbose, and F for use this file. So let's go do this. So first off, let's remove 1, 2, and 3, and they're gone. And then let's type tar xvf and minifiles.tar. Let's see what we've got. And notice that the minifiles.tar file is still there, and 1, 2, and 3 have been extracted from minifiles.tar. Let's see some of the other commands we can use with tar, some of the arguments. And notice that we have create. Here's a t -- list, r -- append, -- delete. And so we saw the C before for create. If we'd like to append a file to the end of the archive, we can use -r. We'll do that in a second. The -t means to list the contents of the archive. X for extract, so on. We can, in a second, we'll see how we can use compression with this. Okay, so look at this. We could spend an entire month just on working with tar, but we're not going to. We use the most used commands. Clear this. Let's go back, and we'll list the contents of that file. So that was it was T, right? Notice that I'm not using the dash. What else do we need? Well, I'm going to be using the file names. So list, here's the file, minifiles.tar. Oops, misspelled it. Minifiles.tar, and there are the contents. So I'm listing the contents of the file. Let's append a file to that. What do we got? Sort.txt. Okay, that's know what that is. Let's copy sort.txt to that directory, and we'll name that 4. We'll cd to compare. Is that there? There's 4, so that's a different file. 1, 2, and 3 were copies of the same file, so let's append that. So tar, and we need append, and we need a file name, right? Now we're going to give that file name minifiles.tar, and we're going to append 4 to that. Now we can arrow back up and list the contents of minifiles.tar, and now we have 1, 2, 3, and 4. Let's go in and let's remove 1, 2, 3, and 4 from that directory. And let's extract those again. There's 1, 2, 3, and 4. Let's remove those files once again, and we won't use the verbose command. We'll just use X and F. How about that? Let's see if we see anything. What's the difference? It doesn't show us what we're doing. or what that command does. And they're the files. They've been extracted. So when do you want to use a V and when you don't want to use a V? Well, I'll tell you personally, it doesn't really matter for small files or small archives. If you've got thousands of files, it will actually take longer if you use the V command because it takes time to write that to the screen. And so if you looked at the difference in time it took to extract a large archive file, one displaying to the screen and one not displaying to the screen, the one that is not displayed to the screen, that is leaving out the V, will execute much more quickly, I guarantee it. Okay, let's do a couple of types of compression here. So let's remove minifiles.tar. And so we're left with those 4 files. And so, well, how do we compress? Well, there's one argument, or excuse me, there's actually 2 arguments that you can use. One of which is, remember unzip? We'll start with that. So we're going to use tar. We're going to create a file, and let's make it, we use verbose. We're going to use the file, and there's one more command we need, or one more argument we need to use, and that is the Z. And Z means to gzip it, to gzip this file. So we're going to tar the file, and then we're going to gzip it. And so we need to give it the name of the file, gzip.tar. We'll call it something different. And now we want 1, 2, 3, 4. Okay, let's hit enter. I hope you're following along. Let me give you a second to type that out. It was verbose. Let's go back and look at this. What should we have done here? Remember when we did this before? This was like 20,000 bytes. Now it's only 2174. Look at how much space we saved by using the gzip compression with this tar command. One thing I don't like about what we did was the fact that I don't know that that's a gzipped file because we didn't use the some kind of extension that tells us it's gz. So unlike when you type gzip in the name of a file, it doesn't automatically add the .gz extension. So let's remove gzipped.tar. Let's arrow back up. Are you following along? Pause the video if you need to. Now there's a couple of different naming conventions that you can use, and you'll see both of them, both in class and outside in the real world. One is to do this. Oops. .gz. What does that tell you? It's a tarred and gzipped file. So let's hit enter. Did it make a difference in the file size? No, but now I know that's a tarred and gzipped file because of that gz extension. Another naming convention, we'll go back up and we'll redo this. Here's the other naming convention, tgz, and I kind of like that. It's a little shorter, but that says it's a tarred gzipped file. Let's go ahead and hit enter, and let's arrow back up to ls-al. There we go. These are both gzipped. We have 4, 1, 3, and 2 inside of these tarred and gzipped files. Let's clear this. Did you get the same thing? Okay, what if I wanted to look at the contents of that file? Ah, it's gzipped. Do we need to do anything differently? T for list and F for file, gzipped.tgz. They're the contents. Okay, so we've got our gzipped file. What if we wanted to extract that? Let's remove 1, 2, 3, and 4. What do we have here? We've just got those 2 gzipped files. What if we wanted to untar and ungzip those files? Do we need use gunzip? Usually you don't all by itself. You know what that's going to do is that will definitely unzip those files. But normally what we want to do is to both ungzip them and untar them and make them all separate files again. Let me run this gunzip gzip.tgz and see what happens. Guess what we're going to have? We have the gzip.tar file. That was the size of it originally, and now it's been ungzipped, but it's still tarred, right? So let's clear the screen, and what we're left with that one file. Remember, the extension doesn't matter. We know it's a tarred gzip file. Hey, in fact, let's do this. I'll show you it doesn't matter. Whoops. Gzipped. We'll just call it gzipped. Let's run file on this. Remember what that does? Hey, it tells us it's a compressed file. It's still a tarred gzip file. So let's move it back to we'll change its name, we'll rename it, go back. Come on. gzip.tgz. See, it doesn't matter. It still knows that it's a gzip file. Okay, so let's untar it, ungzip it, and untar it in one fell swoop. So we want to extract. We want it to be verbose. We're going to use the file, and we need one more thing. See the Z? If we're using the X to extract, the Z at the end says ungzip the file. Remember when we used C before, it says to create. Whoops. We use this, it said to create it and gzip it. This says extract it and ungzip it. 1, 2, 3, 4, and there it is. Okay, one more command. We're going to use the bzip2 algorithm and see how that compares. So it works with tars, it turns out. So we want to create a new archive file. We want it to be verbose. I'm going to use the file to be named shortly. And as it turns out, the J, which is not a good mnemonic, but I don't know why I use J, but J is used for bzip files, bzip2. So we're going to call this bzip.tbz, or you can use tar.bz2. So let's use that. So that tells us a tarred bzip2 file, and now we need to put, let's just use star, well, we can't use, if we use star, what's going to happen here? If we use star, it is going to do what? It is going to try to include gzip.tgz in the archive. I don't want that. I just want 1, 2, 3, and 4. So in this instance, 2, 3, and 4. It's really easy. I've only got 4 files. Let's create it. That looks familiar, right? Let's do ls-al. And there's our bzip.tar.bz2. What if we listed tar, tf, bzip, tar.bz2? What was the T for? The list? Hey, it works just fine. Works just fine. So, if we want to unbzip it, what do we do? What do you think we do? First of all, let's remove 1, 2, 3, and 4. How do we do that? Tar, extract, verbose, file, J. bzip.tar.bz2. Are they there? Are they the same? Yes. Let's go back up and remove 1, 2, 3, 4. I'm just showing you that it doesn't. Now if we moved bzip2 to bzip.tbz2, we could do that. And we could use extract, verify J, bzipped, and there are files. Okay, so that is a nice little demonstration on how to archive and compress files. Hey, what if we wanted to use zip? Let's use zip and see what happens. Let's go to man zip. It should have a good example at the bottom of what to use, and just shows you that if you do download a zip file, you can unzip it. Notice here this is talking about archiving a directory, and the directory is called foo, and you can read that up here if you want. Notice that foo file 1 and foo file 2, the directory contains foo file 1 and foo file 2, or more concisely -r foo, and it's going to add a zip. Notice that the zip extension will be added here because you indicate as such. And so, hey, let's actually do that. Here we go. We're going to make a directory called foo. We're going to go into foo, and we're going to touch. Oh shoot! Let's copy some of those files down, because otherwise it's not going to compress anything. Let's copy 1 to foo file 1, right? And copy 1 to foo file 2. There we go. So we have file 1 and file 2. So this is exactly what we were shown before. And so this is going to use zip-r for recursive. And we're going to call this foo.zip and type foo, which is the directory. Notice this gives us a little more information, adding foo. It deflated by 59%. Remember that we calculated that that's about what we gained, or did I say 69? I think I said 69. And 59% for file 1. Let's see what we've got in here. And we still have our foo. We should have file 1 and file 2 under here, and here's foo.zip. Foo.zip. Okay, let's remove foo. Remember, the -r means recursive and F means force. And so foo is gone as long as file 1 and file 2 under there. And now let's unzip foo.zip. See what happens. Notice it says it's inflating it, and it created that directory. There's foo. Let's go under foo, and there is file 1 and file 2. Okay, so that ends this demonstration on archiving and compressing. You should have followed along and done exactly what I did. You could have used other files. It really doesn't matter. You know, if you have other files on there, you can practice with them. But it shows you can save a lot of space, and there's lots of different options. And when somebody gives you a TGZ file, which I might do later on in the class, you know how to archive and uncompress it.